Well, good afternoon, everyone. These are some disclaimers. I'll let you a few seconds to pass through it. So, how many of you here have experienced issues while connecting to office portals, applications, or even servers sometimes? Anyone? I bet you did, Bharat. And how many of you have felt you don't know what exactly the issue is, whether it's your laptop or office network or the application itself is slow? Yeah? Often, we tend to go to our colleagues and ask, hey, is it working for you? It's not working for me. And it always feels better if it's not working for everyone. And how many of you have been in jittery Zoom calls or lagging video calls? I think many of us have had that experience. So did we. And that's exactly what we are addressing here today. In this session, we will go over VMware ENI, that's Edge Network Intelligence, and see how it helps to overcome these issues. So, quick agenda for today. We'll be discussing about few challenges in the edge monitoring space today. We'll go over the overview of ENI, that's the deployment model, the architecture, and the different data sources from which ENI can gather data. We will go over a few of the use cases that we found useful, and we will see the key benefits that ENI provides. And you can come to us with your questions offline. We'll be here to talk. And with that, I'll hand over to Bharat to talk about a few of the challenges that we are facing in today's era.
Okay. Well, in the previous slide, we discussed about the end user issues. In this slide, we're going to talk about the challenges from the IT side when an end user reported an issue. So, during pandemic and as on now, we are still following the hybrid work culture, and the users are connected from remote locations. But still, it's an IT responsibility to provide and assist them with their issues. So today, enterprise infrastructure becoming more complex than ever, especially at the edge side. So the network processes a huge volume of data and a wide range of application sources, wide range of networks and devices as well. And not having a right product to assess the end-to-end connectivity, it is always the operational challenge for the IT to fix and identify the problem. And of course, the lack of observable systems will add on other challenges as well. So, I still remember during the pandemic, there was a user-reported issue saying that there is a jittery Zoom call and his VPN getting disconnected every time. And as an IT, we took a lot of time to identify the issue, and finally we got to know there was an issue with the Wi-Fi band he's connected on. Like he was connected on a 5 gigahertz, and he's sitting a little far from the Wi-Fi router. That's the reason the signal strength was very less, and his VPN and every application was disconnected very frequently. So we took more than half a day to fix and identify those issues. So those are the challenges basically as an IT we did see during the pandemic as remote users, because we don't see any product which can give you end-to-end connectivity from the end user side.
Yeah, thanks for bringing up that. So, we think we need to move on from traditional operations approach. To be specific, we need to move on from static to AI ops. Gone are the days when we had static systems which collect data and you just have one single rule or alert to trigger that alert. In the era of AI, we need tools that gather data, analyze them over a period of time, learn the changes in the system, and come up with deviations for these alerts. To add on to that, we need to also shift from traditional monitoring approach to observability. So traditional monitoring approach is something when you get to know the issue when something is wrong. But in today's world, we need observable platforms which collect data, gather them from different touchpoints, monitoring touchpoints, for deeper analysis. because the end goal is not just to identify an incident and resolve it, but to deliver a desirable user experience.
Unlike a reactive approach to identify the problem, it is always essential to follow the proactive method. We all know that reactive approach will time consuming and it would potentially impact the user experience and the productivity. And today's systems should be empowered with the self-healing ability. To achieve a self-healing ability, we need systems with AIOps capability and proactive recommendation would lay a foundation for self-healing. Effectively, IT teams is looking for a simple automated solution which can provide more insight on the end user experience and end-to-end connectivity. To have this achieved, IT teams should be equipped with the right set of tools which can provide you more in detailed end-to-end network connectivity. So a quick recap that we discussed about the end user issues and we discussed about the challenges from the IT side, and we know what we need and we have what we have now. VMware Edge Network Intelligence, known as VMware ENI. So VMware ENI is a SaaS-based solution. It also supports private cloud and on-premise. VMware ENI uses machine learning algorithms and data analytics to process huge volume of dispersed data into some meaningful insights. And here the quick architecture of ENI, and it works for all the users who are working from remote, office, and anywhere. And it also supports the IoT devices. VMware ENI is also capable to monitor the enterprise Wi-Fi infrastructure. In VMware IT, we adopted to monitor the Wi-Fi infrastructure in our office. So it supports wireless LAN, and network services like DNS, DHCP, Radius, servers. The client app, which will be in the client side, and it is natively integrated with the VMware Velo SD-WAN. And also it supports the application integration with the application, as we mentioned here, a couple of things like Zoom, Salesforce, Azure, and Google Cloud, so on. And these are the data sources for the ENI. When you are in the branch or campus office, it collects the data from the LAN and wireless LAN, like wireless controller, access points where you are connected on. If you're wired, then it collects the data from the access switches where you're plugged in. And it also collects data from the packet. So it uses the switch port analyzer to collect the packet details. And it also collects the data from the network services like Radius, DHCP, DNS. It also measures the DNS timeout, DHCP latency and all. And the application metrics like application latency, application jitter, and application response time as well. And when it comes to SD-WAN, it collects the application flow metrics from the Velo, Edge, and Hub. When you're connected from home, there will be an agent which will be installed in your laptop, and it will keep sending the data to the ENI. It collects the data from the client app, and it also collects the application metrics from your edge machine to the respective application you're accessing into.
With that, we'll move on to use cases. So 3 years ago, the world ended up in pandemic, and most of the users went remote, meaning working from home. That brought up a lot of challenge to organizations to keep up with employee productivity and to deliver desirable user experience. So let's see how ENI helps us do that. Client app is a component of ENI which can be installed in end user devices like mobiles, Windows laptops, or Mac laptops. And once you install that, you get this user interface which has 4 different divisions. You have the device details, that is the end user device details, because most of the time what happens is The issue is not with the network or your office VPN connectivity. It's with the end user devices. There might be high CPU utilization, memory utilization, or the device is just old. So ENI gives you the overall score and health of end users. Second one is your Wi-Fi network, that is your local Wi-Fi network. ENI tells us how good is your Wi-Fi strength, what's the speed of that, how good your gateway responding. It does a ping check for every 5 minutes for your gateway and gives us the status. And the third one is with the internet. ENI does a series of low-performing synthetic tests for some of the pre-configured websites and keep track of the latency, average response time, and gives you an overall score of how your internet connectivity is. And again, it is similar to VPN. It tracks off all your internal websites and gives you the results of latency and average response time. So let's see a demo of all this. How to navigate with the portal and what all details you could find. So you have the Wi-Fi details here, and it says your signal is mediocre, and you have the details of the SSID, DHCP, and your router, all these details. And again, with the VPN reachability, you have destination sites, and you have high latency marked for the sites which are having latency issues. Yeah. So we know that ENI collects all this data and gives us the status of this. But what does ENI do with this data? It analyzes this and compares this data. For example, suppose you are trying to access GitHub and your average response time is 1 minute. ENI compares this data with industry benchmark, and it finds out that the industry benchmark is 10 milliseconds. Now you know that you have a horrible connection. Again, ENI compares this data with different users across the world. And it's same for the VPN users, that's the internal websites. If you're trying to access Jira, Zoom, something like that, it collects all your data, the response time, high latency, and it compares this data with other users in your organization and gives you an overall score of how good is your connection. Again, if you find any issues while accessing these, ENI automatically creates an incident for you and finds out what would be the reason. That's whether it's your local laptop issues or a local Wi-Fi issues, whether the signal is not good or the VPN itself is down or having issues, or the application itself is slow. It does this with comparing data with all the end users that are accessing these at current point of time and creates an incident out of that. Let's see a short demo on what all details we could get in that. So you have all the root causes observed is client-side Wi-Fi issues, poor client Wi-Fi SNR. And you get this data with each and every metric. That is for your local Wi-Fi. You could also get this for DNS, whether your DNS resolution time is up to mark or not. You could get this for VPN connection, the gateway reachability. You also will have this data for applications that you are accessing. For example, if you are accessing Zoom, using Zoom most of the time in the day, it collects the data from the Zoom of all the meetings that you have attended and gives you an overall performance of the Zoom. That's how good was your audio quality, how good was your video quality, and many more. You have multiple application integrations with ENI so that it gives you the accessibility information for that.
In this use case, how VMware IT adopted this tool as an enterprise Wi-Fi monitoring. VMware ENI supports for SNMP v2, v3, and it also supports for the AMON protocol, which is Aruba's proprietary protocol. So in this demo, we are going to just take you through the controller view, how it looks like. So we have selected one of the controller from the Singapore, and in this dashboard, you'll be able to see the same, what are the access points which are connected, and what are the models and number of clients which are connected to. Sorry. So you can also see the group and custom group which you have created, AP state, and if you see any recent flaps, you'll be able to see it in the flapping column. Play model.
It's not working. Oops. Sorry about that. It's a demo, so the video is stack.
And in the same dashboard, you'll be able to see the charts which are related to the Wi-Fi metrics, which is radius core, AMON messages, SNMP get messages, and CPU and memory utilization of the controller, and radius accept and reject ratio, and completed time, and the radius average transaction time. If it is increased, so you might be seeing a lot of radius authentication issues from the ClearPass servers. This is the access. Next slide. This is the access point view where you can able to select any of the access point, and these are the details you will be able to see in this page, and access point group and access point MAC address, IP address, which is related to the access point and radio properties. And also, you'll be able to see the clients who are connected on the access points and their model, device model numbers, and which band they are connected on. And this shows the charts with the access point details like channel utilization, again, the Wi-Fi metrics, and client count. You will be able to see if you see any drop in the client count during the session, and that you can able to get an incident in the right side. And we just picked up one of the most common issues users will be facing during the Zoom call, and we are just going on a demo on the Zoom call issues. So in the incidents, you'll be able to see this is the trend of the incidents with the severity, and here you'll be able to see the priorities we have selected, and description of the issues and the affected users or affected device here, and just click on the affected device, and Zoom is the top one, and out of 221 clients, like 94 clients are facing some issues, and which is compared to the baseline, which is more than the baseline. So, and which AP group they are connected on, and what are the client count based upon the 75% of the clients, which is TCP latency. And if you just click on the 16% clients, and you'll be able to see that TCP retransmit rate was high. That's the reason that might be the issues. And 3 clients were showing it's a Wi-Fi performance issues. If you just click further on the client side, so the dashboard looks like this. So it shows further details on the client. Client is connected on which access point, and what could be the issues. Like if you see here, it's showing retransmission rate was high on the 5 gigahertz, causing these issues. And it shows in the chart as well, like Wi-Fi performance index dropped just because of the Wi-Fi SNR was like signal to noise ratio was down there. So bad SNR was causing the Wi-Fi performance issues.
Yeah, just to add to that, all of these metrics are clickable. So once you click that, you'll get more details, and you can go on to the detailed report of these things. And ENI especially helps us as a self-diagnostic tool before going into an IT administrator with problems to find out where my issue is, whether it's my laptop or office network or the internet connectivity, or if it's the application itself. And to sum up the benefits or the use cases from what we have seen here, ENI is not just a monitoring tool, or it's not just an analytics tool. It's a combination of both. It's a combination of monitoring and analytics. So it gathers data from multiple touch points from the edge devices, analyze them over a period of time, and gives you recommendations and correlate these data with other data sources.
ENI provides a better end-user experience by correlating the data of the infrastructure and application both. So any issues for the end user, you can separate it on infrastructure and application. Most of the time, we have seen it falls under application, it falls under network, it falls under other infra. So this tool will help us to correlate them and provide the exact data of what happened during the issues.
Yep. We'll be here for any questions that you could ask us. And please take the survey. Thanks. Thanks, everyone.
Thank you. Survey.